Today I found one of my new favorite toys. This is the Louisiana Department of Education LEAP test, and they have put out, I think, my absolute favorite standardized test. I'm not going to work through all of these items today, but I do want to show you some of these items and the Desmos calculator and how you can use it to do the items. And then this is teaser alert. I'm going to be creating something this week. It will probably be more traditional test, but I will give you test types and items to mimic some of these really good items. I want to show you how to do this. I'm going to send you the link to this page that you're looking at right now in the notes so that you can log into this practice test and do these items with me. So if you'll pause the video and look down at the notes, the show notes for this, you can find the link and you can go in and do these items as I'm doing them and play around with the tools. It's a really cool test. Typing in the username math and the password test1234, you'll sign in to this test and then it'll give you some information. This is your training. It's a training site for students and for whoever, people like me who care about tests. And then you're going to click on mathematics, which is the only test available. And then you're going to go in. Now, having said that, the mathematics in this test is a lot of different mathematics. It's got geometry, it's got algebra, and we're not going to work through every single item in the test, but I am going to work through a few, mainly the ones that deal well with the calculator, things you can do on the calculator with your students and that will help them not just get the item correct, but really access the curriculum. And I love it. I love the way they've handled this. All right, so as you click through, it's going to basically give you all these instructions. These are the ones the kids actually get on their tests on test day. And we're going to begin the test. I love this item. This is a table, and you are asked to predict the height in inches on day 55, and then you're asked to write an equation. Now, that is the order they want you to go in, but you don't have to do that. You can actually go backward, and so that's exactly what we're going to do. Unfortunately, this thing scrolls down, and there is an answer choice D, which I don't like because a lot of times kids won't know there is a fourth answer choice. But we're going to go ahead and create this table using this calculator. Fortunately, this graphing tool is the Desmos calculator, not this one. This is a handheld, like a scientific calculator. We want to use this graphing calculator for this problem. So on the top left corner, we're going to click on Table, and we're going to recreate this table. So we got 10, 20, 30, and 40. Now the Y1, what we're going to do, I'm going to go ahead and put these in here. 4, 8, 12, 16. Now there's a couple of ways to approach this problem, but what I'm going to do instead is I'm actually going to use the function notation here. So let's do h of t equals 4t. And I'm going to add a column to my table and call it h of x1. Now, why are we doing that? Let me move this over so you can see. Because the input in this table is x1, not just x. So they need to put not h of x, but h of x1, and not h of t because there is no t defined in this table. You could change that to t, but they'll want it to be a t1, so you might as well just put x1. So now you can see that this equation, h of t, does not work for this problem, so we're going to change this to 1/4 t. This is answer choice B. And that does not work either because these are not matching. And then we'll do 5/2 t. And those are not working either. And then, of course, the last answer choice is correct. And unfortunately, that's the one that went off the screen. So hopefully, I don't know. I hope that's not really a problem in their actual test, but it should be viewable. But this is the correct answer choice. So the kids would click here to choose it. I love the fact that you can leave this open and answer questions, because this part is super easy now, because I'm asking on day 55. Well, these are days on the left, 10, 20, 30, 40 days. So all I have to do is put a 55 in here and it outputs the 22 in the far right column for the function h of t. So the correct answer here is 22. So this is a fantastic, I just can't, sorry I'm gushing, but this is the best type of item for Desmos. It is designed to really handle questions like this. And kids have to know a lot of mathematics to be able to do this, but it's not too, tedious or challenging for them. So it's really a nice tool. Let's move on to the next question. We are still looking at the same table of values, the same scenario, but this time we're asked to graph the function h. Well, the table has points on the graph of the function h, so we're going to use the calculator again to actually graph 2 of these points. Now, you can recreate the whole table, but if you're lazy like me, you don't really want to create the whole table. You don't have to. You can just create a couple of these points. So I'm going to do 10, 4, and 28. Now, in order to see these points, I need to adjust my window to match the one that's here on the actual test. So the wrench in the top right corner, we're going to make our number of days go from 0 to 40. So let's call this X. We'll go from 0 to 40. And since it is counting by fives, we'll use a step of 5. The y-axis is going from 0 to 16. 0 to 16. And we'll put the y here. And the step here, it looks like it's counting by 2s. If you'll remove the minor grid lines, it will look more like the test. All right, what's cool about this is now I can see the 2 points that I'm supposed to be graphing, and I can see exactly where to graph them. I'm going to zoom out just a hair so I can see that outer axis. So I know the first point is 10, 4. It says choose this one, so click on 10, 4. Unfortunately, nothing happens when you click. You have to actually go to the next point, which is here. Well, I said that, and then it didn't work. This is hard. 10, 4. And then you're going to go to 28, which I did not label that one. Okay, let me label that one. Okay. And so you can see 28, 10, 4. And if you mess up, you can click the eraser and do again. Unfortunately, what I've learned through practicing these items is when you click eraser, it deletes everything. So if you've got quite a bit going on, you really are having to start over. That is one thing I wish they'd change, but I do love this problem too. So the calculator is very helpful in helping them plot points, find them, and we can even graph this line. But we'd have to make the table, so I'm just going to go ahead and pass on that. All right, let's go ahead to the next question. Now, this has nothing to do with the calculator, but I'll go ahead and answer it anyway. We're asked for the domain, so that would be the time in days, and time is not just measured in integers, which is counting numbers, or non-negative integers, or all real numbers, but it would be all non-negative real numbers, because you can measure any amount of time you want. This one is only counting by positive integers, but you could put 10.25 days if you wanted, and yeah. So I went ahead and did that one, but that's not really something we can do on Desmos. The next question is also really awesome for Desmos calculator, and it gives you a parabola with A, B, and C. These are called sliders in Desmos. So go ahead and click on the graphing tool, which is the Desmos calculator, and type exactly this equation with the A, B, and C in it. Shift 6 is a exponent, but they do have the keyboard down at the bottom, so you can use that to make exponents. And then we're going to click on all because we want to create sliders out of that. Now, you may want to warn your kids the A, we normally do not change from 1. So generally speaking, don't move A until you've tried everything you can with B or C. And that's because normally in Algebra 1, especially on a problem like this one, they're going to stick to parabolas that are shaped like the parent function. So they're not steeper, they're not fatter, they're just your standard parabola. And they're just going to move it around in the graph. So what it wants us to do is have a minimum point at 2 negative 1. And so I'm going to label this point. And then it also wants a y-intercept of 3. Now, if they don't know how to graph the y-intercept 0, 3, they'll quickly notice it when they type. I typoed. Let me fix that. It's 0, 3 here. So if they actually did 3, 0, they would see it's not on the y-axis, and hopefully they'd correct their mistake. But our goal is to get this parabola to hit those 2 points without changing A. So let's see, if we move it a little bit left and right, I'm not sure what I'm doing there. I'm going to put it here. And then I know C needs to move down. All right, let's move it left and right again. So B is moving the graph left and right. C is moving it up and down. And then A, we're not going to mess with that. So you'll notice I've already gotten it to line up just perfectly. And I have my values for A, B, and C. And that's just how quick it is. The kids will be surprised. They will quickly find these values. Sliders are fantastic. So if you're not using them in your instruction, I so recommend it. All right, so the value for A was 1, like I said. You can put in A values that they have here. So if the kids want to do -1, 1, and 2 and just pick between those 3, they'll quickly figure out 1 is the only one that makes sense. B is 2, and C is -1. So those are the 3 values that we need. Now, here's the kicker. When they go to the next screen, they're going to ask questions about this problem. So my suggestion is that you write down or have your students write on their scratch paper that A is +1, B is +2, and C is -1. Because when they get to the next screen, this is gone. And what's worse is I don't think, let's see if I'm right. If I go back and I click on the calculator, yeah, everything I did on that calculator is now gone. So they do need to write this down, unfortunately, for this problem, which most kids aren't going to write it down. So they'll end up having to redo the problem on this screen. So let's go ahead and type in, instead of A, B, and C, let's just put the A in that we know now. A was 1. B was 2, so x minus 2, and C was -1. So I'll just put -1, or you can put plus -1. It works either way. So we've recreated the parabola that was on the last screen. So the next question is what are the x-intercepts of the parabola? So let's click here and click here, and the x-intercepts are the 1 and the 3. Now be careful, the 0 is not the x-intercept. That's 0 on the right is your y-coordinate. It's not anything x about it. So let's choose 1 and let's choose 3. Now if your kids are confused about the 0 part, one way to find x-intercepts is to type x equals 1 and see if it goes through the x-axis and the parabola, and it does. And then x equals 3, and it goes through the x-axis and the parabola. And see, if you did x equals 0, it doesn't go through the x-axis at 0. It's going through the x-axis at 0, but it's the y-coordinate of 3, so that's not what we want. So let's choose the points 3, 1, and 3. Continuing on, we're working through a table of values, and this one's another one that's so good for Desmos. We're going to use the graphing tool, which is the Desmos graphing calculator. We are going to recreate this table. Now, for this problem, I'm actually going to leave it y1, and I'm going to show you why. Go ahead and type -1, 3, 7, and 11. I appreciate them not giving like a whole ton of points to type, because as we know, the more the kids have to type, the more likely they'll mess it up. All right, so I'm going to use y1, and this is why. If you haven't taught your kids how to do regression equations on Desmos, here's how you do it. You type y1 and then tilde. It's over there to the left of your 1 on your keyboard if you don't know where that is. Shift and then the number to the left of 1 is your tilde. And then do mx1 plus b. Now, let me point out, when you type the 1, it automatically subscripts it, so there's no shifting or anything to get the subscript. You don't have to use any special thing. It does it automatically. So you may think, well, wait a minute, these numbers do not appear in this as these options. So what we're going to do is we're going to type y equals m. Instead of m, let's replace it with 0.75 x plus b, which is minus 7.25. Now, we don't want 0.75, so 0.75. Now, this is on their test now. They're going to let them convert that to a fraction by clicking this box here, or this little button here, and that is a 3/4. So we know it's y equals 3/4. See, it's 0.75 x plus, all right, well, it's minus. So let's do 7.25. Well, actually, let's do plus because we're going to enter a negative. All right, so negative 7.25 as a fraction is negative 29/4. So that's telling you to choose 3/4 for x and negative 29/4 for y. Now, obviously, if the kids can find the slope in the table on their own, they can just put that in and then try the others until they find it. That's another strategy that will, that's pretty simple. But I highly recommend this regression equation if you've never used it with your students. It's so nice. And then to convert, it does that as well. The beauty of this Louisiana calculator they use for their state test is they're not taking anything out. They're leaving all the functionality so the kids are able to really enjoy the calculator. You may notice this little plus here. This is Zoom Fit. It'll even adjust the window of a graph to fit the data in the table, which is awesome because they're not spending so much time messing with their window trying to see the graph. They can quickly get about, whatever the problem's about. So this is a fantastic problem. I'm sorry I keep gushing, but I just love this test. Let's go on to the next item. Now, I have skipped through quite a few problems. One was solving a literal equation, and sadly, the Desmos calculator is not much help with that problem. And the geometry, I've gone ahead and skipped some of that as well. But this one is something that's really challenging. I'm not sure a lot of kids are even going to do this problem. But for the kids that want to do this problem, there is something that the calculator can do to help them. So I just wanted to show it to you as a tool to use with students when you're teaching this concept, and they can at least check their work as they go. It won't help them do it, and it'll give them the solutions, but it's not going to help them solve the problem. So the first thing we're going to do is we're going to type in the equation that you're given exactly as it appears. Now you'll notice you see a parabola here, but as soon as you do equals 0, you're going to see a vertical line. But actually there's two vertical lines. So you got to move out. I'm zooming out. It's kind of cool that the zoom works on this. And this intersects the x-axis at -14 and +2. So as we're doing these problems, we always want to keep in mind that we need to go through the points -14 and +2, because these are the solutions to this equation. So we've got the solutions. But if we want to complete the square, what we will do is we will do the steps in the calculator. And as we do them, if we've gotten it correct, we haven't messed it up, each step will give you the same two solutions. So the first step in completing the square, of course, is to add the constant to both sides. So we're going to add 28 to get the 28 from the left to the right. So let's see, we'll end up with x squared plus 12x equals 28. And so now when I turn this off, you see the red one there? There's the blue one. I know I didn't make a mistake. This step is, at least if they know how to complete the square, that step works. So the next thing we're going to do is we take half the coefficient of x and square it. So half of 12 is 6, squared is 36, and that is a constant that we will add to both sides. So I'm going to type in, actually, let me show you this. They can copy this, Control C, and paste it. So all they have to do is add a 36 to both sides. And I'm going to scoot this over so you can see all of that. And I'm still seeing the same 2 points. See, the blue one's under there, so I have not messed up. Now the next thing I do is I write the left side as a binomial squared. So this is x plus 6 squared. And the right side, go ahead and combine 28 plus 36. And if you're like me, you need to type it out. So I'm going to do it right here. 28 plus 36 is 64. And again, right on top of there. So each step of the way, I'm using the calculator to check my work. Now, when you take the square root of both sides, you're going to get x plus 6 equals 8. But you'll notice only one of these turned red. We still have the purple one underneath here that's not represented. So that'll help your kids know there's two answers. I'm going to make this one red as well so it matches the one below, the one right above it. So x plus 6 equals 8, x plus 6 equals negative 8, and we got those same 2 points. So then we solve each one, subtract 6 from 8, we get x equals 2. I did that one in green, so we'll do this one in green. X equals, subtract 6 from negative 8, negative 14. Let's make this one green because these go together. Okay. All right, look at that. So the solutions are 2 and negative 14. And again, whoops, wait a minute. I didn't change it to green. There we go. So these are my solutions, 2 and negative 14. So in the equation editor, we are going to click on the equation editor, and then we're just basically going to copy this into the equation editor, and you really don't have to go out at all. You know what? I'm going to skip that step because that was given. Let's go ahead and start with the 28, and then we did x squared. We'll go ahead and put a 64 here. Then x, parentheses, x plus 6 squared. This looks pretty bad in this equation editor they have. But it's functional. All right, then x plus 6 equals 8. X plus 6 equals negative 8. X equals 2. X equals negative, what was that, 14? Let me scroll down over here. Well, maybe not because it might go out. And then we click OK, and it puts all of that work right here. So, yeah, it's probably not many students that are going to do this problem, I'll be honest. It's hard to get them to do them in class when you're teaching it. But for the kids that are going to do it, this is a fantastic tool to guide them and help them see if they've got a calculation error or if they missed a step or they just got something wrong. It'll show them because you want to continually stay on those same two solutions the entire process. Let's go to the next question. Okay, so this one's a little different too. We can use the Desmos calculator, but you're not going to be able, I don't think we're going to be able to use the slider, but let me show you what I mean. If I do x squared plus 12x plus c, it'll put slider, but as soon as I do equals 0, it's giving me this thing that says you can only do x and y. So it's not an implicit equation anyway. C is a constant. So what you want to do is get rid of the plus 0 altogether and just leave it a C and do the slider. So what you have here is a parabola, and we're going to move the parabola up and down. I need to go way higher. So let's make this 10 way bigger. Let's say 50, so that I can keep sliding up. And I want to keep doing that until there's one and only one solution. Well, the kids will have to know that one solution means one x-intercept of -6. So be careful. The answer is not -6. That is your x-intercept, and that is your solution. But the value of C that made that one x-intercept of -6, which is 36. So I don't know if they're going to take this answer because I haven't really looked at their scoring guide yet, but I would tell the kids the answer is 36. And they're going to want you to talk about perfect square trinomials and all that, but I wouldn't do that. So let me go ahead and I'll pause this and show you what I would type in for this answer. So here's what I put for the explanation. One explanation the kids might use. The graph y equals x squared plus 12x plus 36. If they do leave off the y equals, they should say the function x squared plus 12x plus 36. They can say that expression is a function. And the vertex of the function, or the equation y equals, has a vertex at -6, 0. And that's the only solution because the vertex is the only x-intercept in that graph. Something like that. Now, I'm sure they're wanting to talk about perfect square trinomials and the two factors are the same. There's a double zero or something like that. But this is a true statement and should be sufficient for this answer on this test. Let's go to the next question. Now, this question I first was excited about until I read the question again. This looks like a regression equation type question, but this is not at all, and this table is super confusing. It's not that helpful. It's just showing that the weight loss for each of the candles is close. They're all close to 0.5, 0.6, 0.7. So it's 0.56 or something, I think, is the average of those numbers. This is not what you think. I'm not going to do this problem because honestly, the equation, the calculator is not going to help you much on this one. It's just a general knowledge of direct variation is what this is. So I'm skipping this question. If I had one thing to tell Louisiana, this is a bad question. It's going to mislead a lot of kids, so hopefully they don't really put one like that on their state test. So the next question we're going to tackle is question 10. Again, I'm sticking to algebra, so I've skipped through quite a few items on this test. And this is another one where the calculator will be very, very helpful to students. We're going to graph the line segment JK with these coordinate points. But first, I'm going to find those coordinate points in the graphing calculator, Desmos, to kind of guide me. And I'm going to also try to recreate this a little bit to make it look a little bit more like what they're seeing on their paper. One thing I don't like about this tool is they don't let you enlarge or shrink this calculator. Now you can zoom in and out, so you can make this as big or small as you want, but you can't really stretch it, which is unfortunate because I probably would if I were testing. I'd want to do that. So I'm going to go ahead and graph these 2 points, -4, 11, and 8, -1. And I am labeling both by clicking the little box on each point. Okay, I can see both of these points on my screen. But you know, this just doesn't look that much like the paper. Maybe I can go to it. Let's see. Let's go ahead and label this X, label this Y, and let's go ahead and put -11 to 11, count by ones. -11 to 11 and count by ones. I want it zoomed square and I don't want minor grid lines. So look at that. That's pretty similar. Oop, if I zoom in, it's not going to work. Now, one cool thing you can do is move this around. You can also close those points because they're not that helpful. You can zoom in and out. If the kids have a mouse, they can use the roller wheel on the mouse. That's the easiest way. They can also use this. But they don't want to scroll out too far or in too far to lose those grid lines. And they will lose them because Desmos will try to, when they get to be too many, they'll turn off some of them. So our goal is to plot this point, but this one says to use the line segment tool. You're going to use this first one, which is so confusing. See, this one, it extends beyond the points, and we don't want to do that. So we have to use this tool. And we're going to graph on -4, 11. So left 4, up 11. And they can use their actual calculator to kind of gauge where to go. And once they click on it, well, I said that, but I didn't do it. -4, 11. There it goes. And then we're going to go to 8, -1, which I hate it, but it's right there. So there you go. And then they can double check. Am I in the right spot? 8, -1, -4, 11. Yeah, that looks good. Now that's the easy part. The next part is not as easy. So what I want to do, and I'm going to use this to do it. I'm going to zoom in. Is I need to add points to the graph right here, like every, I don't know, let's see. We're supposed to basically draw a line through these points on here. Can't do that on Desmos. You're going to have to graph a line. So if they know how, they can. That would help them. Or you know what? Let me try something here. Okay, there is a way that we can create this line, and that's with a table. So if the kids insert a table and just put the 2 points in the table, click and hold this little button right in front of Y1, and down at the bottom, it's going to give you lines. Turn that on, and it will make a line segment for you. So that's a lot of work, but it's kind of cool because the cool thing about this line is I can scroll down this line and see points on this line. Or maybe not. So I've got points, and I want to divide this into ratios of, let's see, find 2 possible locations for point M so that M divides it into 2 parts with a ratio of 3 to 1, 1 to 3. All right, so I know I've got 4 equal parts, and one is, you'll use 1 part and 3 parts. So what we can do is try to eyeball the midpoint, and it looks like the midpoint is at 2, 5. So I'm going to add 2, 5 to this graph. And then I'm going to divide both of those in half to get 4 equal parts. So let's divide this one into 2 parts by putting the point -1, 8, looks like. This would be a fun problem to work as a class and let your kids just kind of play with it and see what they come up with. You'd be surprised. How can you get a ratio of 3 to 1, class? Just let them try it. Ooh. And if they mess up, seeing it's not on the line, they got a quick check just by looking at the calculator. So these points are on the line. So get a ratio of 2 to 1, 1 to 3, I mean, 1, 2, 3, 4. So I would do 1 segment, and then this segment has 3. So I could use the point -1, 8, and I could use the point 5, 2, because I'd have a segment 1 and then 3 just like it up here. So I'm going to say don't use 2, 5. Let's unlabel that one. Oh, I did already. And let's label these 2. These 2 look like they're working. 5, 2 will work because it cuts it into a ratio of 1 to 3. And -1, 8 works. So let's use that, and let's see if that'll help us plot points. Now we're supposed to plot the point. So I'm going to click up here, and then I'm going to go to, let's do -1, 8 first. It's right here. And then the other point is 5, 2. Okay, so those are the 2 possible points that we could choose to divide that into a ratio of 1 to 3. Now, if your kids are anything like mine, they wouldn't even have noticed that question. They probably would have just graphed the line segment and moved on from there. But as a class, this is a great item, an exercise to practice together for their state test. Let's go on to the next item. Now, the last item I'm going to do is item 12 or question 12. So let's look at that. It says the sum is what? Well, they will have to know what these words mean, rational or irrational, but can be written as a fraction. So let's see if that's true. I'm going to do 1/3 plus square root of 5. Type SQRT. That's the keyboard shortcut for square root of 5. Hit the right arrow before you hit divide, which is your backslash right next to your period on your keyboard. I'm telling you that because my students, if they're like your students, they prefer typing it to using the keyboard at the bottom of the graphing tool. You'll notice this does not give them the option to make a fraction at all here, and that's because this number is irrational. Irrational means ugly is what I tell them. You're irrational, you're not very nice. So we say irrational for that. The sum cannot be expressed as a single fraction because the fraction option is not even present in the graphing tool. So that's a clue. The next one is 20 divided by SQRT, and then we put 16. And it is a 5. Now, it's not giving me the fraction here either, but it is a 5. So we're going to say it's rational because the quotient is equal to an integer. It's nice. Having the square root of the denominator doesn't matter because square root is 16. If they don't know it, they can type SQRT. 16 is also an integer, so it's the ratio of two integers, 20 to 4, which is the same as 5. Anyway, just a little helpful, not a whole lot of help. They have to really know quite a bit about the term rational, irrational, ratio of two integers. But they can at least use the calculator to calculate to see if it's coming out nice. And if they can make a fraction. See, 1.07, if I type that, I've got a fraction. But if I type all this, I don't know. Will it still give it to me? It might. Yeah, if I keep typing for a while, notice how that fraction option goes away because it thinks, okay, you're typing like a ton of digits. So anyway, just a little hint or clue that would give them one little bit of assistance on this item. Now you can see I have not answered all of the questions, but you see the check marks on the ones that we did together. So that's a pretty good chunk of questions that the Desmos calculator, at least for most of those, the Desmos calculator helped us, gave us a little bit of help. So I encourage you to check out this test and stay tuned till next Monday because I'm going to hopefully give you a test that has some of the same types of items, things you can use with your kids. So maybe you could do this as a class activity, go through some of these same items together, and then maybe give them a little quick assessment using their Desmos graphing calculator to help them. Now, if you are in Louisiana giving this assessment, it is important that they're using the calculator that they'll be using on their state test when they're doing these practice items. Of course, it's in the test, but let's say you're taking another test with, that you're creating for your kids or one that you've gotten for your kids. And the one I'm going to give you next week, if you want to use it, they can still use the same calculator by going to desmos.com and clicking on Math Tools, Practice Test, and then at the top choose Assessment. And this one's Louisiana, so I'm going to use Louisiana LEAP 2025. And then they'll click on Start Practice. And so this calculator will mimic the functionality of the Louisiana calculator. So if anything's been disabled or taken out, the kids won't have access to it. And that way they'll kind of know how to work around that or work with that functionality on their regular assignments, that it's not a shock to them when they get on their state test. They know what to expect from their graphing calculator. Hopefully this has been helpful to you. If you have any questions about any of these items or comments or suggestions, things you would like to see in the assessment, because I'm going to be writing this assessment for this week. So if you've got something in particular you'd love to see added to this assessment, let me know. And until then, y'all have a great day.